Morning, Natalie. Good morning, Devana. Let me see. Okay, let's see who's in the waiting room. Nobody else is in the waiting room. Okay, I think we'll get started with doing, as I said, I'm going to do that second question first, and then I will give you a little time to do this one as well. Okay, this question is a simplification of radicals. That was the beginning of chapter 6. Actually, this is where we're going to be starting off our sessions today. So let's just review how we simplify a radical. Remember, this is a square root. Even though we can do this, radical sign is used for not just square roots, but for cube roots, etc. We are really going to concentrate on the square root and working with square roots. Again, remember, it looks like a division sign. Usually there's a number inside the check mark that is called the index that tells you how many times you're multiplying to get the number inside. When there is no number there, the index is understood to be 2. That's why it's called a square root. Square root means a number when you multiply by self. So you're multiplying two numbers together that will give you the number that's inside the radical sign. If you recall what we said yesterday, is we're going to, if unless these are perfect squares, there actually are numbers that when you multiply them by themselves will give you this number. What you try to do is break it up into two radicals. In the first radical, you're going to put all of the what we call the perfect squares, the numbers that have square roots. Anything that's left over will go in the second radical. So actually we do it piece by piece. We start with the number 48 and think what two numbers multiplied together will give us 48, but and one of them has to be a perfect square. One of them I can take the square root of. Actually mentioned yesterday, there were two options. You could do 4 times 12, because 4 is a perfect square, or you could do 16 times 3. And the rule is, if you have two choices, you want to pick the one that gives you the larger perfect square. So we're going to break the 48 into 16, which is a perfect square, and 3. That's what's left over. Then we go to the variable. Now, what we said, we're working with the variables is actually easier, because what you're doing with the variable is you're taking the exponent and dividing it by the index. In this case, the exponent is 5, and remember, when no index is written in, it's understood to be 2, and I would get 5 divided by 2. Now, we really don't want to be left, there's nothing wrong with fractional exponents, but when you want to simplify, you only want to have whole number exponents. So if your exponent does not divide evenly by 2, it's not even, in other words, then you break it up. The a to the 5th, you take one away from it, you're left with a to the 4th, which is a perfect square because 4 is divisible by 2. And obviously, we're left with a plain a over here, because a to the 4th times 8 of the 1, remember when you're multiplying, you would add their exponents, would give you a to the 5th. Then you go to the next variable, which is the b. And notice the b's exponent is 8, and 8 is divisible by 2. 8 is an even number. So I don't have to split it up. I can go, it's a perfect square. It goes right in the front radical. So step number 1. Yes, question?
I just turned my mic on by accident.
I'm sorry?
I just accidentally turned my mic on. I'm sorry.
I don't know who's speaking.
That was Emma. She turned her mic on by accident.
Because I'm not hearing you. I'm getting very unclear.
It was Emma. I think she's turned her mic on by accident.
Oh, okay. Thank you. Thank you. All right. So step number 1, separate your radical when you want to simplify it into 2 pieces. The first piece is going to be a perfect square. So it's going to be easy to take the square root. The second one is what's going to be left over. So the square, now I'm up to that point. I take the square root of 16. Remember the number, the coefficient, I'm actually taking the square root of. So the square root of 16 is 4. Then I do the letters, I take their square roots by dividing their exponents by 2, because again, my index is 2. So 4 divided by 2 is 2. So this is going to give me a squared. And 8 divided by 2 is 4, and it's going to give me b to the 4th. That's no longer inside a radical because I have taken its square root, and then times radical 3a. So that's, and this would be my answer. It doesn't look so simple. The technical, because there's so much going on here. It's 4a squared b 4th, not in a radical, times radical 3a. But what makes it the simplified form is the fact that the number inside the radical is as small as we could possibly make it. So that's how we would simplify an expression like this that's inside a radical. Okay, now let's look. Does anybody need time to copy this? Okay, so then I'm going to erase this so we can work on this top example, which is a long division example, which is also something that we had talked about on Thursday. We have actually something that has 4 terms, a polynomial, that we're dividing by a binomial. And when we do that kind of division, we have to set it up like a long division problem. We take the divisor, the thing we're dividing by, put it on the outside, the dividend, that's what we're dividing into, the 4x2, 3, plus 4x squared, plus 13x, plus 6 inside my radical, making sure that all the terms are in descending order, which they are. We have a 3, a 2, a 1 exponent, then no x. And if anything would be missing, any term, like if I started with an x cubed, and the next thing I see is an x squared, and then I go and I see a number and I don't see any x term, I have to put a 0 x for it so that every single term is accounted for. Once we do that, then we're going to follow 4 steps.
So we're not simplifying this, we're solving it.
We're dividing. It's called
Divide, yeah.
It's not a simplification, because with simplification, I'd have to be able to factor it. And with dividing, we do this long division. It's like
Got
saying
it.
I could factor 15 into 5 and 3, because 5 times 3 gives me 15. But if I have 15 and I want to divide it by 2, that's a division. That's not a factoring. It's the same idea. So this is what we're doing, though, is we're making sure to do the 4 steps. We divide, multiply, subtract, bring down. Remember those 4 steps. So to make life simpler, instead of working with this whole 2x plus 1, which is very hard to work with, I just work with a 2x. I take the first term and divide it into my first term. So 2 divided into 4 gives me 2. And x into x cubed, remember when we're dealing with the letters, we're subtracting their exponents. So this is an exponent of 3, this is an exponent of 2, this gives me 2x squared. So I done step number 1, I've divided. I then take what I just put on top, which is the 2x squared, and multiply it by the divisor. Now when I do, even though with the division part, I only use the first number, when I'm doing the multiplication part, I have to use everything. I first multiply the 2x squared times the 2x, which gives me 4x to the third. And then I take the 2x squared and multiply it by the 1, and that gives me 2x squared. Next step is to subtract. Now, remember what I told you to do. When you're subtracting, in this case, the easiest way to do it is to change the sign of your set of your what you're subtracting, which is the second line. This is actually a positive 4x cubed, so it's going to become a negative. This is a positive, I'm going to change it to a negative as well. If this would have been negative, I would have made it positive. I changed the sign, and then I just combine down. So here I have a 4x cubed and a negative 4x cubed. Obviously that gets canceled out. Then I do 4x squared minus 2x squared, which gives me 2x squared. So now I've subtracted. The next thing is to bring down. I go to the next term, which is the 13x, and I bring it down. And now I start again with the division. I again take the first term, the 2x, and divide it into the 2x squared. Well, the 2 into the 2 cancels out, and the x into x squared gives me x. So on top, I don't just put x, I do plus x, because it's either going to have to be plus or minus. I can't just have separate terms there. I have to have them connected. I don't know, I look at it. This is a positive into a positive. This is going to be a positive. You put that x on top, and then you multiply by what you just put on top, which is the x. X times 2x is 2x squared. And x times 1 is just x, or 1x. And again, we're at the subtraction stage. So I'm going to make this a negative because it's a positive. And I'm going to make this a negative because it's also a positive. And I combine 2x squared and negative 2x squared canceled. 13x and negative x give me a positive 12x. I bring down the 12x. I bring down the 6, the next term. And I again do the division again. 2x into 12x. So the 2 into the 12 gives me positive 6. And the x's cancel out because x into x, when you subtract the exponents, you get 0. That means there's no x's left. It's just, again, if it's x into x, you get 1. You don't get any x's. After you put the number on top, you take what you just put on top, which is a 6, and multiply by it. 6 times 2x is 12x. 6 times 1 is 6. And again, We subtract by changing the sign. This again becomes a negative. This also becomes a negative. They just happened that all these signs turned out to be positive. But whatever the sign is, you change it to the opposite. 12x and negative 12x cancel out. 6 and negative 6 cancel out. There's no remainder. So my answer is 2x squared plus x plus 6. If there would have been a number remaining here, then we would have taken that number. If it was positive, I do plus. If it was negative, I do negative. That number on top of the divisor as your remainder. In this case, there was no remainder. It actually divided in evenly. Is there anybody who has any questions about this? Okay, let me just mention, if you read the email that I sent this morning, by after class, there will be a test available for you, quiz number 3 on Delta Math. I am giving you until next Friday to do it, and I actually gave you a whole hour and a half to work on it, though you will not need an hour and a half. Again, once you start doing it, you have to finish it in one setting. I will be reviewing today at the end of the period, and also on Tuesday, some of the types of questions you will see on this quiz. So if you want to, you can wait until after Tuesday to work on it. I also, because these are more difficult questions, gave you for each question 3 attempts. You could do it 3 times. If you don't get it, and if you get it right by the 3rd time, you get full credit for it. So as I said, I tried to make it a little simpler by giving you another chance. If you see that you do a problem, it'll give you tell you right away whether your answer is correct or not. And if it's incorrect, it'll tell you you have another chance to do that problem. Again, you will get 3 attempts on each problem. Does anybody have any questions they want to ask me? Okay, so then does anybody need me to leave this still on the board?
I'm somewhat stuck. Like, I don't understand how you got the answer.
Do you know which step is your, or would you like me to do another example like this? Should we just work through another example like this?
Yeah, I would like it if we did it again. I don't really get it.
What I'm going to do is, okay, so I'm going to look for an example that came off one of our old finals and see if we can, I'll give you a few minutes to try one let me see if I can find an old final that we can do a problem from. Here, can I erase this now? I'm going to give you one to try. I'm going to give you time to try it again. This is from a final, so I'm going to not only give you the example, I'm going to give you the choices. And You're going to see if you can work this out. Okay, it says divide. Four x squared plus 6x minus 1 by 2x plus 1. And I'm going to put the possible solutions here. Here are your choices. A is 2x plus 2 minus 3 over 2x plus 1. Choice B, 2x plus 4 minus 5 over 2x plus 1. Choice C, 2x plus 2 plus 3 over 2x plus 1. And choice D is 2x minus 2 minus 3 over 2x plus 1. Okay. While you're working on this, I'm going to take attendance, and then we'll go over this problem together. Azia, I see you're here.
Yes, Professor.
Nashia Allen. Anna Belkis. Emma, I know you're here.
I'm here.
Good morning. Messiah. Messiah here? Corey?
Did you say me, Corey? I'm here.
Good morning. April?
Good morning.
Khadija? Khadija here? Umar?
Hello.
Good morning. I see Nashia is here. So let me change this. Yakima. Yakima here? Cheryl, I know you're here. Stacy, I know you're here. Denisha? Denisha? Denisha here? Devonna, I know you're here. Natalie, I know you're here. Erica, I know you're here. Jonathan, I know you're here. Luke. Luke Minot here. Luke. Layla.
Yes, Professor, I'm here.
Good morning. Ashley.
I'm here.
Good morning.
Good morning.
Kachira, I see you right there. Kachira, were you here yesterday? No, she hears me.
No.
Correct. Jennifer,
Right here.
good morning. Rachel, I've seen you here. I know Rachel is here.
Good morning, I'm here.
And Gloria.
Professor, I'm present. That's Corby.
Who is that?
Devonna.
Oh, okay, good.
Good morning, professors. Erica, I'm here.
Who's that?
Erica,
Erica, yeah, I know you're here. I said you. I saw
thank
you.
you.
Is Denisha here? That's what I don't, thought I saw Denisha. Okay. Let's see if I can see if I can, on the participants. Denisha is here, so obviously she's not. So she's not, not hearing me.
Oh, it's Jonathan. I'm here. I don't know if you said my name, but I'm here.
Jonathan, I know you're here.
Oh, okay. Sorry.
What I usually do is if I talk to somebody or I notice their name come up, then I right away mark them here. So
Oh,
just
okay.
save some time. This is for everybody. So sometimes if you don't hear your name, it probably means that I saw that you were here.
Yeah.
Okay. Okay, let's now quickly but carefully go through this example. I saw some people sent me what they thought was the correct answer, and some people did have it correct and some people didn't, but let's do it. Again, it says divide, and since what I'm dividing by is a binomial, I have to set it up like a long division. I put the 2x plus 1 on the outside and the 4x squared plus 6x minus 1 on the inside. Now, as I wrote it, I was very careful to check that it was in descending order and that nothing is missing. Then I start my division. I take the 2x, which is my first term, and divide it into the 4x squared. So the 2 divides into the 2 and gives me, into the 4 and gives me 2. And the x into the x squared gives me x. So the first thing I put on top is 2x. I take what I put on top and multiply. 2x times 2x is 4x squared. And 2x times 1 is 2x. So step number 1 was to do the division, where I just do by the first to make it a simpler division. And then the second step is to multiply. Now I'm up to subtraction. So I'm going to take, since I want to subtract this 4x squared plus 2x, I'm going to change the sign. This is going to become a negative. This is going to become a negative. And I'm going to be left with 4x squared minus 4x squared, which cancels out, and 6x minus 2x, which is 4x. And I bring down the next term, which is negative 1. And now I divide the 2x into the 4x. So the 2 goes into the 4, positive 2, and the x's cancel out. So I just put a plus 2 on the top. And I take what I just put on top, which is the positive 2, and multiply by it. 2 times 2x is 4x. 2 times 1 is negative. 2 times 1 is positive 2. Better watch my signs. Now I'm going to change my signs because I want to subtract. So again, this is going to become a negative. This is going to become a negative. And the 4x minus the 4x cancels. And I now have negative 1 minus 2. Well, negative 1 and negative 2 give me negative 3. So my remainder is negative 3. So my answer becomes 2x plus 2. And my remainder, my negative 3, I put over the 2x plus 1. And if you notice, answer number A and answer number C are almost identical. The only difference being that one has a plus and one has a minus. And here you could have done all the work correctly. And if you just made a mistake and put this as just a regular 3 instead of a negative 3, you would have gotten that problem wrong. So here's where you have to be really careful with your signs and working your question. Does this make this process clearer? Any questions about it? I see, wait, it's A, okay. Good, I see, Emma, you corrected yourself. Okay, so those people who sent me in the answers all got it right. So now I think we can now go on from there. I think we should now continue with our study of radical and working with radicals. I would like to talk about how we add and subtract radicals and how we multiply radicals. If we can do adding, subtracting, and multiplying of radicals today, I think we will have accomplished quite a bit of work. And on top of that, I would like to spend at least the last half hour of the class just reviewing of certain problems that you're going to encounter on the quiz on Delta Math. I'm going to give you, I mean, obviously I'm not doing the exact problem, I'm doing similar problems so that if you have any questions, again, you have until next Friday to do the exam on Delta Math. I think I put it at, I'm going to change the time. I think I made it due in the morning, but I'm going to change it to at night, that you'll have until tomorrow, a week from today in the evening to finish this quiz. You do not have to do it over the weekend, but if you do want to do it, I did assign, I think, an hour and a half, which is at least double the time that you'll need for the quiz. It's 10 questions. You should be able to do them. Okay, now what I want to do is I'm going to erase this and I'm going to go back to working with radicals. Okay. We did spend quite a bit of time on Thursday talking about how to simplify radicals. And one of the major reasons we need to know how to simplify radicals is because the rule for adding and subtracting of radicals is very similar to the rule that we have for adding and subtracting of like terms. We can only add like radicals. What does that mean? If I give you something like 3 times square radical 5 minus 7 times radical 5, These are called like radicals because the numbers, whatever is in the radical is identical. The only thing that's different is what we call the coefficient, the number on the outside. Now this is telling me I have 3 times radical 5 and we're subtracting 7 times radical 5. It's similar to having 3x minus 7x. Instead of having a variable, we have a radical. But these are like radicals because they are identical, just like these are like terms because the letter parts are the same. And just like the rule for combining like terms is you just work with the coefficients. In other words, you do the 3 minus 7, which gives you -4, and your answer becomes -4x. When you're combining radicals, you do the same thing. You leave what's inside the radical alone. You do not touch that. You just combine the numbers on the outside. 3 minus 7 again is -4. So your answer becomes -4 radical 5. So in a way, it's not, the rule is very similar to a rule that you're really familiar with. Combining radicals means combining the numbers in front of like radicals. And when I say like radicals, this has to be, if this is a square root, this can't be a cube root. This can't have an index of 3 where this has an index of 2. The radicals have to be the exact same index. Again, the questions we're going to do are basically going to be with square roots. And the numbers inside the radicals have to be identical. So what if I were to give you this question? Two times radical 75. This is off the sheets that the chapter 6 sheets. Minus radical 48. Plus 3 radical 12. What if I said, here's an example. I want you to combine this. Well, my first reaction is, well, this has a 75 in the radical, this has a 48 in the radical, and this has a 12. None of them are like radicals. They all have different numbers inside their radical. But that was
Because the 12 and the 48 aren't like,
what?
the 12 and the 48 don't count as like, even
Yeah.
though 12 goes into 48.
They have to be identical, the exact same number. There's a 48 here. They are not, the only thing that would be another 48. It can't be just because, oh, 12 goes into 48, maybe they're like. No, they identical. It has to be, it's like you can't, an x and an x squared. They both have x's, but they're not like terms. But here what we can do is make use of what we learned on Thursday and try and simplify each of the radicals. And after we've simplified the radicals, then we're going to examine and we're going to see if we can find like radicals. So let's look at this 2 radical 75. And I'm gonna worry about the 2 later. I'm gonna look at the 75. What could I break up 75 into so that one number is a perfect square and one number is not? What numbers can we break 75 up into? Any suggestions?
25 and 3.
Right, because 25 is a perfect square. So I'm going to put the 25 first, and 25 times 3 is going to give me the 75. Now I know then I can take the square root of 25, which is 5, and that will give me 5 radical 3. But don't forget, there was originally, this 5 radical 3 is the square root of 75, but there was originally a 2 in front of it. And since there's nothing in between the 2 and the radical 75, it must be that the operation is multiplication. I have to take this 2 and multiply it by the 5 radical 3. And the basic rule is, if the numbers are outside, you can multiply them together. You can't take a number that's outside a radical and multiply it by a number inside a radical. But if you have 2 numbers outside the radical, they can be multiplied together. 2 numbers inside radicals can be multiplied together. So in the end, this becomes 2 times 5, which is 10. So this becomes 10 radical 3. So I simplified 2 radical 75 into 10 radical 3. Now I go to the next, the 48. Somehow 48 happens to be a very popular number in a radical. And we've already done that. We know that the 48 can be broken up into 16 and 3. And the radical 16 is 4. So this becomes 4 radical 3. Don't forget there was a negative in front of this. So my next radical becomes minus 4 radical 3. And finally, the radical 12, I can break up into 4 and 3 because 4 times 3 is 12. And the square root of 4 is 2. So this is 2 radical 3. But again, I had that 3 that was on the outside. So I take the 3 on the outside and now multiply it by the 2 on the outside. So that becomes plus, because this was plus, 6 radical 3. So notice what's happened is that after I have simplified all my radicals, they now are like radicals. And now I can combine them. Remember, by just combining the numbers on the outside. 10 and negative 4 is 6. 6 plus 6 is 12. My final answer becomes 12 on the outside times radical 3. So if you know how to simplify a radical, then you can combine, and when you simplify them, you might then get like radicals, and then you would be able to combine them. Let me see if I can give you an example to try. And this actually is off a final exam, so you'll get an idea of what we're looking at. Here's the question. Radical 50 plus 3 radical 128 plus 4 radical 162. See if you could simplify these radicals, somehow come up with an answer, because as they stand now, they are not like radicals. I'm going to give you a couple minutes to look at that. Okay, I think we should work on this together. What did you split the 50 up into? Anybody?
It'd be 25, square root of 25 and 2.
Right. The perfect square that goes into 50 is 25. So this is going to be the square root of 25 and the square root of 2. And again, the 25 is a perfect square, so I can take that out of that radical. So it becomes 5 on the outside, radical 2. Notice I always try to put the number in front that's the perfect square, because that's what's going to come out of the radical. Okay, what about this 128? How could I break up the 128? Any ideas? Anybody come up with anything that 128 breaks up into? Nobody? Well, I'll tell you what I see. This doesn't always work. But if you notice that this thing ended up with a 2 in the inside, I'm going to try and
64 and 2.
right.
Because you said if it has a 2, then I gotta put the other 2. So 64 and 2.
Yeah, now that doesn't always work because nobody's promising me that these things are going to be like radicals. But when they give this as a question, yeah, they're probably going to turn out to be right radicals. So I just try it. And when I divide the 128 by 2, I get 64, which is a perfect square. So I'm going to break this up into 64 and 2. Don't forget there's this 3 on the outside. I'm going to take care of that later. The square root of 64 is 8. Remember, once I take its square root, it's no longer in the radical. This stays the 2 because it's not a perfect square. And now I have this 3 on the outside that I have to multiply. Again, since the 3 is outside, I can only multiply it with a number that's outside. That's the basic rule. Outside numbers can be multiplied by outside numbers, inside numbers by inside numbers. So 3 times 8 is going to give me 24. So the next thing gives me 24 radical 2. Okay, now I look at this 162. Anybody have any ideas what to break up the 162 into?
I put 81 and 2.
Perfect. Again, this was a 2 and this was a 2. Try 2. And here's a good suggestion. If you're trying to simplify a radical, now some of those, if you have one of those, I think TI-80, the TI, and I think it's a TI like 32 or 34. Some of them actually will simplify the radicals for you if you put it in what's called math mode or math. So if you have a calculator, you're not quite sure how to use it, you can. If you send me a picture, I can probably give you some instructions on it. But it's always a good idea to try and divide the number inside the radical, if it's not a perfect square, by a number like 2 or 3 or even, let's say 5. Easy numbers, and see if that makes the other number a perfect square. And you're right, this becomes 81 and 2 because 2 times 81 is 162. And the square root of 81 is 9. So this is 9 radical 2 that again, I'm going to have to multiply by this 4. The 4 times the 9 will give you 36 radical 2. And now we see that they are all like radicals. So I just add the numbers in the front. 5 and 24 happens to be 29. 29 and 36 is 65. So my answer becomes 65 radical 2. Be careful with your signs. In this case, all the signs were positive. But the final answer was this simple answer of 65 radical 2. So again, in order to combine, which means add or subtract radicals, they have to be like radicals. And sometimes by simplifying your radicals, you will get like radicals. Sometimes you won't. Sometimes two of them will be alike and the third one won't. You can only combine the ones that are like radicals. Okay. Is that clear? Okay, so then let's see what happens when we try to multiply. Said I'd like to be able to do adding and subtracting, which we've now done. Simplify the radicals and then just add or subtract the numbers in front of the coefficients. Let's work with multiplying of radicals. Okay, so I'm going to erase this. Anybody need more time? Okay. And first I'm going to multiply two monomials. This is a monomial because it's just connected by multiplication, and this is connected by multiplication. Then we'll go to multiplying a monomial times a polynomial, and we really know the rules, and then we'll talk about multiplying polynomials. Okay. And we'll see that the rules of working with the radicals is really all the same rules that we've learned all along when we're multiplying with variables. Just like when you're adding and subtracting, you need like terms, you need like variables. You need like radicals. But when you're multiplying, you don't have to have like radicals. You can multiply two radicals together as long as they both have the same index. Again, I'm only working with square roots, but if one was a square root and one had an index of 3, it was a cube root, I would not be able to multiply them. This is just so that if you go into your next class, you'll know how to handle it, even if we didn't cover that particular topic. What is the rule for multiplication? Well, I sort of said it already. You take the numbers that are outside the radicals and multiply them together. So 3 times 7 is 21. And then you take the numbers that are inside the radicals and you multiply those together. So 7 times 14, I'm going to do on my calculator, gives me 98. So that is the short and simple. Multiply numbers outside together, multiply numbers inside together. Do not multiply a number that's outside a radical with a number that's inside. So outsides by outsides, insides by insides. The only thing that's left to do is simplify, because usually what we would like to do is give our answer in simplest form. Now, if you notice, if you were to divide this 98 by 2, you would have gotten 49, and 49 is a perfect square. So this would be the square root of 49 times the square root of 2. In other words, we're doing exactly what we learned before, is simplifying the radical. The square root of 49 is 7. I have to take that 7 and multiply it by the 21. I could also, I'm going to do that on my calculator. 21 times 7 gives me 147. So my final answer becomes 147 radical 2. So again, we don't have to do the simplification with the adding and subtracting. We simplify first before we can add or subtract. With a multiplication, we can do the multiplication first and then simplify. Sometimes you can try simplifying first. If you notice, I couldn't have done anything with the 7 and the 14. 7 is only 7 times 1 and 14 is only 7 times 2. Neither of those would have worked for simplification purposes because you need one of the numbers to be a perfect square. But when we got to 98, we could break it up into the 49 and 2 because 49 is a perfect square. So usually it's better in these is to do the simplification at the very end. Let's try one more. Suppose I gave you 6 radical 30 times 10 radical 3. Okay, I'm going to give you a couple minutes to try this one. David? David? Okay, let's work with this one on the top. It's not too hard to do. Again, we have a monomial, 6 radical 30, times another monomial, 10 radical 3. We know they're monomials because I don't see any pluses or minuses in between. I take the numbers on the outside and I multiply. 6 times 10 is 60. And then I take the numbers that are inside the radicals, the 30 and the 3, and I multiply them. And I get 90. And I just want to see if I can possibly simplify the number that's inside the radical. Remember, the number that's outside the radical, I don't have to worry about simplifying. It's outside the radical. It doesn't need any simplification. It is in simplest form. But this 90, I could break up into 9 and 10. And we know the square root of 90 is 3. So I take the 60, which is outside the radical, and multiply by the 3. 3 times 60 is 180. And radical 10. Now I can't, even though 10 can be broken down into 2 and 5, neither 2 nor 5 is a perfect square. So I can't simplify my square root of 10 any further. So my final answer here is 180 radical 10. Again, don't forget, after you've done the multiplication, you try to simplify. Now, I've actually put a second question over here. And if you notice, this second question is a little bit different because I have a single radical, a monomial, square root of 5, which is understood to have a 1 on the outside because there's nothing outside it, times a binomial, 3 radical 10 minus 4 radical 5. Now, these are not like radicals, so they can't be combined. I could try to simplify them, but neither 10 nor 5 is can be simplified. So I'm multiplying a monomial times a polynomial. And we know that in algebra, when we have a single term times multiple terms, we have to use the distributive property. Now, all the algebraic rules work here. So I'm going to have to take this radical 5, which is on the outside, and multiply by each of the terms on the inside. So first I'm going to take the radical 5 and multiply it by the 3 radical 10. And remember, it's understood there's a 1 here. So 1 times 3 gives me 3. 5 times 10 gives me radical 50. Then I go to the second term, and I also multiply the radical 5 times a negative 4 radical 5. Again, the 1 times a negative 4 is negative 4. And radical 5 times radical 5 is radical 25. And now I want to simplify them. Now the radical 50, I know I can break up into 25 and 2. And the radical 25 is 5. So I multiply this 3, which is on the outside, with the 5 that's on the outside now, and that gives me 15 radical 2. Then I go to this radical 25. Now, radical 25 is itself a perfect square. Actually, the radical 25 is just plain 5. So this becomes just 4 times 5, which is minus 20. Now, don't try and combine these any further because these are not like radicals. This has a radical 2 next to it. It's like having an x next to it, and this is like a number that doesn't have any x at all. This is your answer, 15 radical 2 minus radical 20. And that's as simple as your answer is going to get. I do want to make a comment about here. I multiplied radical 5 times radical 5.
Professor, that's 15 radical 2 minus 20.
Yes.
Okay.
I want to make a statement about multiplying something like, I'm going to do it, let me do a different problem. Suppose I had 3 radical 7 times 5 radical 7. Again, these are 2 monomials. Now, obviously, when I multiply the numbers on the outside, the 3 times the 5 is 15. Those are outside the radicals. When I multiply the radical 7 times the radical 7, I'm going to get radical 49, which is just equal to 7. Think about it. Anytime you're multiplying a radical by itself, like radical 7 times radical 7, the number you're going to get is going to be a perfect square that you'll be able to take its radical and just get the number. The radical 7 times the radical 7 will just give you 7. The radical 5 times the radical 5 just gives you 5. It's a shortcut. Why go to the trouble of doing 7 times 7 getting 49 and then taking the square root, when I know if I want to give a general rule that if I multiply the square root of x times the square root of x, it's just going to give me x. Anytime you multiply a radical by itself, it just removes the square root. Think about it, it makes sense. I'm taking a number, then I'm multiplying by itself and getting the number that you get when you multiply it by itself. So what does that help me? Over here, when I did the 3 times the 5, obviously that gave me the 7. But when I see the radical 7 times the radical 7, I can just write it as plain 7 without going to the intermediate step. But now that 7 is no longer in a radical, so I can multiply the 15 times 7. They're both numbers that are outside radicals. 15 times 7 is 105. And the final answer to this question would be 105. You're multiplying two irrational numbers, two numbers that have radicals in them, but your answer doesn't have any radical because you're multiplying the square root of 7 times the square root of 7. Anytime we get the square root of a number times its square root, you can just remove the square root. You don't have to go through the intermediate steps. Okay, I want to do one more type of problem, which is where we're going to end up here because I want to have a few minutes for review. And after that, what we're doing now, I'm not giving you homework on this. The homework that I gave you only goes through simplifying of radicals. Let me see. Yeah, I guess I will give you homework, but it won't be due until next Thursday. So I'll probably post some homework probably over the weekend. I might post homework on radicals, but it won't be due until next Thursday. I just want to show you how to multiply binomials with radicals. And you know how to multiply binomials in you know how to multiply binomials with variables. The rule is basically the same. In other words, if I were to multiply 2 radical 3 minus 4 times 3 radical 3 plus 2, for example. Notice these are 2 binomials because we have either a plus or a minus between the 2 terms. We know when we multiply binomials, what we use is FOIL. Well, that's exactly what we're going to do over here. When we're going to multiply, we're going to do first, outer, inner, last. We're going to have to do 4 multiplications. We're going to have to double use the distributive property. So first, I'm going to do the 2 radical 3 times the 3 radical 3. So remember, I multiply the numbers on the outside. 2 times 3 is 6. And then I multiply the radicals. Radical 3 times radical 3. Those are the same exact number. So that just gives me the number 3 without any radical at all. In other words, multiplying this by this gives me 6 times 3, which is 18. So that's my first. Now we do outer, which is 2 radical 3 times positive 2. Now I multiply the 2 over here, which is outside the radical, by this 2. It's not inside a radical, so that gives me 4. And the radical 3, there's nothing to multiply by, so I just bring it down. So that becomes 4 radical 3. That's outer. Now we go to inner. Inner are these 2. Again, I take the 4, negative 4, and multiply it by the 3. So that becomes negative 12 radical 3. I am multiplying the number outside by the number outside. There's no radical to multiply by, so I just bring it down. And finally, I do last, which is just -4 times +2, which is just plain 8. Now I look at, I have 4 terms. I look for any like terms. Well, there's an 18 here, so it's not connected to any radical 3. I can combine it with this -8. Those are like terms because they're just plain numbers. 18 and -8 gives me 10. Then I have a 4 radical 3 and a -12 radical 3. Those are also like radicals because they are both connected to radical 3. So I add 4 and -12, which is -8, and I bring down the radical 3. And this would be my answer. Do not try to combine this. Don't do the 10 minus 8 and say it's 2. It's 10 minus 8 radical 3. These are not like radicals. This is like a 10 minus 8x. This is your answer in simplest form. So I'm going to stop here because it's already 11:15. This takes care of all the multiplications. So now we know how to add, subtract, and multiply and simplify radicals. On Tuesday, we will talk about dividing radicals and also what do we do when we want to solve equations with radicals. So that's where we're going to be going from here. Okay.
I have a question. I'm sorry. This may sound like an ignorant question to ask, but since you're a teacher, has this ever been confusing for you? Because I think my relationship with math is that sometimes I get so confused. Like the first half of the semester, it's okay, but now I'm noticing like it's starting to get a little bit more difficult in terms of the objectives and stuff. Oof.
Well, I have to tell you, did I ever have problems? I'm sure I did. It's been a long time. Yes, this is confusing. That's why I find that I know I have to go faster now, simply because I have to finish up all the work. So I am going a little bit fast. That's why I sort of like to do it. I gave you a lot of stuff to handle now, but we're going to review every single thing that I did. That's why I'm not really assigning the homework until that it's due for Thursday on what we learned today, because I'm going to review this very thoroughly on Tuesday as well.
Because just watching you do it was making my brain hurt.
Okay. Did you get it somewhat?
Somewhat, yes.
This last thing, I didn't even give you one to try on your own because I think it's a little bit early for that. I just wanted to present it to you to say, okay, this is all, it's sort of, I thought it might give you a better feeling to say, oh, we've already done adding, subtracting, and multiplying. So we really have accomplished a lot. You'll see as you do problems, you'll see that it really is a lot of the same rules that you use in regular algebra. I think it's just a matter of getting used to it.
Yeah.
Professor,
Yes.
I have a question. Once you did it, I plugged it into my calculator and I did it in my calculator to see, what I would get. So it gave me the same answer that you have, but mine's, it says -8 radical 3 plus 10. So does it matter how you write it?
No, it does not.
Okay, good.
It's like, let me ask you this question. Does it make a difference if I write 10 minus 8x or -8x plus 10? Does it make a difference? Are these two things the same thing?
Sure.
Sure they are. So it's the same thing. That radical, think of that radical 3 as if it's an x. And then it'll it works just like an x. It's like having 10. So therefore you could have easily have said -8 radical 3 plus 10. You just have to be careful to keep the signs with the number. You couldn't change it to a positive 8 radical 3 and a negative 10. But the order does not make a difference. And you'd have to know this because when you got it on a multiple choice, you have to be able to choose, is this the right answer? They're not going to give you a choice between this or this because they're both correct. So you have to be able to recognize if you get your answer in this format and they write the answer in this format, it really means the same thing. If you notice, if you do it on your calculator, if you have one of those calculators that has something, I think it's called Math Print, it will actually do this for you and save you all the work. And I didn't tell you you can't use those calculators. You definitely can. That's why one of these TI graphing calculators is not going to do that for you. It's only the simpler calculators. Who told me they did it on their calculator?
I did, Jennifer.
Jennifer, what calculator do you have?
I don't use my calculator that you have because I don't really understand it. So I have a calculator on my phone that I use.
Oh, okay.
I don't really understand because this it has certain functions and not everybody has the same calculator.
One of these complicated calculators, but I'm not happy with you using just a calculator on your phone. Usually they don't work so well.
Yeah, sometimes they don't. But when it comes down to this, it does. But I'm gonna try to figure out because it came with an instruction manual. I'm gonna try to figure it out.
Truthfully, look at if you're taking your test at home, there's no way I can see if you're sitting with a phone next to you or not. But you're really not supposed to be using a phone when you're taking a test. I
Okay.
guess you'd understand that.
Okay.
Okay, so I would prefer if you get a simple, don't get an expensive calculator. You should be able to get a calculator in the $15 to $20 range, which is
I have it. I just don't really know how to use it.
okay. So you know what? If you want to send me a picture of it, I can tell you which buttons are important for you to use. Or
Okay.
if you want, we could meet, let's say, before class. If you want to
Okay.
come in, let's say 15 minutes earlier than class. If you have sent me a picture earlier, so I'll know which calculator you're dealing with, I'll be able to give you instructions.
Okay, on Tuesday, I'll send you the picture this weekend and then on Tuesday I'll meet you early.
Okay, so just whatever you want to do, just send me an email because I don't remember.
Okay.
Okay, so if you send me an email, I try to, but, and that goes for anybody. If you have something, if you have a piece of equipment and you really need help in how to use it effectively, I can't do a whole class on teaching the calculator because everybody has a different calculator. But if you want, I can spend some time with you doing the calculator. Okay, so where we're going to really start next time is reviewing of multiplying of radicals and then going on to dividing of radicals. Just as a review for the quiz that's on Delta Math, I picked out some problems. I'm going to do a couple today and we'll do some more on Tuesday so that if you want to wait until after Tuesday to work on that quiz, we'll have done a review of basically the type of problems you're going to see. So one type of question is going to be a solving of I'm going to do a couple of equations to solve with fractions. First of all, let's say I ask you to solve this equation, x over 16 equals 4 over x. I'm going to give you a couple minutes to try it on your own, and then we'll do it together. Okay, what would be your first step in solving this kind of an equation? Anybody have any suggestions? Anybody?
You wouldn't cross multiply.
Now, let's put it in the positive. Yes, I would cross multiply.
Okay.
Yes, it is what we call a proportion, one fraction equaling another fraction. So let's cross multiply. So x times x gives me x squared, and 16 times 4 gives me 64. Okay, what do I do from here? Any suggestions? What kind of an equation is this? Is this a regular linear equation?
No, don't we have to like put the parentheses and put like x parentheses x on one side, and then you have to figure out what goes into 64, so it's 8?
Well, before we do that, you have to bring the 64 to the other side. It has an x squared, which means it's a quadratic equation. And if it's a quadratic equation, we want to get it equal to 0. So I'm going to subtract 64 from both sides, which will give me x squared minus 64 equals 0. Remember, you want to get it equal to 0 before you do that factoring. And somebody mentioned in the chat that then you see it's a difference of squares. So you can break it up into x plus 8 and x minus 8. And then you set each of them equal to 0. So we get x plus 8 equals 0 and x minus 8 equals to 0. And if I subtract 8 from both sides, this will give me x equals negative 8 for one answer. And at this, bringing plussing 8 to both sides, this will give me x equals 8. And it's not enough just to write the answer 8. There are two answers. It's a quadratic equation because it has an x squared. So you got to get those two answers. One is negative 8 and one is positive 8. If you get this on a Delta Math test, make sure you write in, don't just write in 8, though 8 is one of the correct answers. It's not a complete correct answer unless you give both solutions. Okay, let's try another example. Okay, can I erase this? Okay, erase this.
Yes.
What if I gave you this equation? Just do this one more, so then we'll know that we're. Suppose I gave you x minus 5 over x minus 7 equals negative 6 over x. What would you do with this one? Let's do this together. Again, I have a proportion. I have the same exact situation. More complicated, but it is the same situation where I have a single fraction over here and a single fraction over here. This is a single fraction, even though there are a lot of things going on here, it's just one thing on top of another thing. So again, I'm going to do that cross multiplying. I'm gonna do the x times the x minus 5 equaling the negative 6 times x minus 7. Remember, when I cross multiply, I end up without, the whole point of solving equations that have fractions is to somehow try and get rid of those fractions, because fractions are hard to deal with. So we'd like to not have to deal with this. Now, of course, I have to remove the parentheses. I have to distribute in order to see what I have here. So this becomes x times x, which is x squared, and x times negative 5, which is negative 5x. On the other side, I have negative 6 times x, which is negative 6.
Negative 6x minus 42 equals 0.
Is it minus 40? What do I get when negative 6 times negative 7?
You get negative 42,
Negative
positive 42.
positive 42.
I see. Equals 0.
Is it equal to 0? No, I have this side equaling to this side. I don't have it equal to 0 yet.
Okay.
But I know I have to get it equal to 0 because I have an x squared. It is a quadratic equation, which means I want to get everything to one side equaling to 0. So I'm going to add. So the first step is just cross multiply. The second step is simplify, get rid of parentheses, regular equations. Then when you see, not always is it going to be a quadratic equation, but if you see it's a quadratic equation, you're going to have to bring everything to one side. So I'm going to add 6x to both sides, and I'm going to subtract 42 from both sides, which will give me x squared. Now, negative 5x and plus 6x is plus 1x, or plus x, and minus 42. And now I've got to factor, or if you prefer, you can use a quadratic formula. Now, these are going to be factorable. I'm going to be looking for, I need to break up, I have 1 times 40, negative 42 is negative 42. So I have to break this up into two numbers that multiply to 42, but when I subtract them, they give me 1. And I guess everybody will realize it's 6 and 7, because 6 times 7 is 42. And since the middle term is positive, I'm going to have to do a plus 7x and a minus 6x. I bring down the x squared and the 42. This then factors in my first group, I get x times x plus 7. And in my second group, I have the 6 and the 42, so I have a common factor of 6. And since I'm starting with a negative, it becomes a negative 6 times x plus 7. So let's see, going over here, I get x plus 7.
¿Qué pongo, mami?
Yeah, sure.
Que me ponga mami.
Espérate.
Am I
Mira
okay?
cómo está. Tiene que quitárselo. Toma el teléfono. Jennifer.
Can I go on?
Mami,
¿Qué es lo que tú le estás haciendo al niño?
¿qué lo estoy haciendo?
Ujú.
Nada, ¿cómo que le estoy haciendo?
Dile a Mana que se quede ahí para que te ayude con él, para yo ir a buscarte.
I muted whoever was going. Sometimes people don't realize they're. So over here, I see I have a common factor of x plus 7. And in the inside, other one, I get an x minus 6. These are both equal to 0. So x plus 7 equals 0. Gives me an answer of x equals negative 7. And x minus 6 equals 0. And I add 6 to both sides. Gives me as my second answer x equals.
Equals 6.
And the only thing I really have to do is to make sure that neither of these answers is an extraneous root. Remember, we have to check when we have in our original in our original equation over here, we have to check to see that the denominator, neither of this question answers make a denominator equal to 0. Now, I don't have time to do a whole check. So I'm just checking the denominators. Using -7, the denominator here is -7 minus 7 over here, which is -7. If you notice, I'm just putting in, I'm ignoring the numerators because the extraneous root comes when you get a 0 in the denominator. Now look at this, -7 minus 7, that's -14. So that's not 0. This is -7. So even though I don't have time to do the whole check, I see if I've done my work correctly, -7 is a good answer. What about with the 6? Trying the 6, the first denominator becomes 6 minus 7, and the other denominator becomes 6. Because this is an x minus 7, this is an x. Now 6 minus 7 is -1, which is also not 0. Neither of these answers make a denominator equal to 0. So both answers are valid answers, and you would have to put in both answers. But always go back after you've gotten your answers and just, even just visually, does that number that I got cause a denominator to be 0? And it doesn't have to be every single denominator. It just has to be any one denominator. If it does, then you have to discard that answer. It's an extraneous root. It can't be used. Okay. So let me reiterate where we're up to at this point. There is some homework on Delta Math, on radicals. I will be over the weekend be putting in more homework that will cover through adding and subtracting of radicals. I won't give you any homework on multiplying of radicals until we redo it on Tuesday. In addition, I have posted a test on Delta Math, a quiz number 3, that is going to be due a week from today on the, today is on the 16th, I guess. Today is the 9th, so a week from today is the 16th. It has, you do not, I was going to say, we will be doing some more review of that on Tuesday. This is some of the questions that we did today are a review for that quiz. Again, I gave you plenty of time. I think I gave you something like an hour and a half to work on it. But again, it has to be completed in one session. Does anybody have any questions they want to ask me at this time? Jonathan, are you a little bit less confused?
I'm a little bit less confused, but I'm just not confident in doing it by myself.
Okay.
I know some parts, but I think if maybe by next week I'll be able to get the hang of it.
Well, that's more the point of the homework on Delta Math is also to give you a lot of practice.
Okay.
Just because I gave you whatever examples I gave you on Delta Math, you can always do more than I gave you. And again, let me keep repeating, if you're behind or you haven't completed all your homeworks, I really will not take off for any homework that was done late. I will give you complete credit. So if you're behind, just make sure if you need something reset, I'll gladly reset it for you. If you want to redo a test or a quiz, I'll gladly reset it for you. Obviously, the only thing I can't reset is the midterm, but I think everybody did fine on the midterm, so I don't think that's a problem. So, but your final grade on this course is going to depend a lot on how much you've put into it. And I see how much effort you've put into it by seeing who responds in class, who shows up to class, and who does their homework. That is, unfortunately, I can't meet you in person, but this is as close to in person as I can get. And I do feel I've gotten to know some of you people personally, just because of this give and take that we can have here on Zoom. So again, if you need anything, and always, if you have a question about something, bring it up. Tell me what your problems are so that I can set it up. I can re-teach it or do it. I'm glad when you tell me, hey, this is bothering me and I need you to go over it again. I need that input from you. Okay, Melissa, are you going to, should I make you the host? Is Melissa here? Melissa? I don't know if she hears me. You know, and I'm going to assign her to be the host, and everybody else. I'm going to be ending session now. I'm going to assign Melissa to be the host. I'll come back and check. If she didn't take over, then I'll just end the session.
Thank you, Professor. Have a nice weekend.
You too. Be well. Enjoy.
Thank you. Enjoy your grandbaby. Have a beautiful weekend.
Thank you. Thank you.
Bye.
Bye-bye.
Bye.
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 You understand?